Okay, this video is going to be kind of an introduction to the class, just some other information. So we're going to start by going over the syllabus, something we would normally do in class, but since this is an online class, we're going to do it here. Okay, and then we're going to talk a little bit about how you turn in homework in more detail. Okay, so here's a syllabus. It's out there on Moodle. Take a look at it anytime that you want. Again, this is an online course. There's no real set meeting time that you have to go to. So that makes things a little bit different than a normal class. We'll figure out some office hours to have. The lecture portion of the class is going to be given via video, so you never have to be there for that. But we will have daily, most likely, office hour meetings or class sessions that are optional, that you can come there, ask questions. We can do some more examples, whatever we have to do to figure stuff out. Okay, so we'll try to, once people join Moodle, I'll put a poll out there or an email or something. We'll figure out a time that will happen. Okay, so this syllabus has the normal stuff in it. There's my cell phone number. You can text on that number. My office number, I'm not there this summer, so there's not much use in that, but you can call me on my cell phone number or text me at that number, or you can email me. Okay, so this course continues on in the programming sequence that you've been on, starting with Python, moving on to C++, and now we're doing data structures using C++. So here's the textbook here. It's Data Structures Using C++, second edition. The book apparently is no longer available through the bookstore. So I guess we have to change at some point. I've used it for a couple of years and like the book, but it's no longer available normally. But you can find online versions. You can find used copies or other copies online, just not from the publisher. Amazon has it, other places. Okay. So in this class, we're going to be working on creating some complex C++ programs, more than we have before. We're going to talk in particular about abstract data types and data structures. Okay. And then we're going to write programs that involve linked lists, trees, stacks, queues, graphs, things like that. Okay. And then another important thing here is to be able to write solutions based on those data structures, to be able to pick out an appropriate data structure to use. Okay. In talking to Dr. Somerville about how you guys did, those of you who just had him, how you did, apparently the syntax was coming along okay, but one of the issues is knowing how to go about solving a problem. So we're going to try, whenever possible, given the abbreviated summer format, we're going to try to work on those reasoning skills to be able to figure out how to get to a problem solution. Okay. As far as the grading, remember, grading is not, Moodle is going to give us grades, just, everything weighed equally. And I'll try to fix that. Apparently there's a way to do it. But if not, you can always do it yourself in Excel or you can write a program if you want. Then basically there'll be labs every Friday. We'll try to find a time we can all meet. If not, we'll have to work in groups where you had me for lab before, so you know what labs are like. There'll be a midterm and a final. Those are each worth 20% each. The lab's worth 10%. And then the programming assignments are the bulk of the grade. Half the grade are from programming assignments. Okay. So the numeric grade is 90, 80, 70, 60, just like always. Okay. The in-class policy things don't make a lot of sense since we're not going to be in class. Okay. But it is true that there will be no makeup exams unless you let me know in advance. The exam dates are going to be out there from the start, so there shouldn't be any issues there. Okay. In programming classes, it's always a little trickier than one might expect when it comes to plagiarism and cheating. Okay, so basically your program should be your own. If it's a homework assignment, I encourage you to work with other students to talk about the program, to let them, give you some ideas of how they're starting to do things and all that. But when it comes down to creating your program, it should be you typing it in yourself. Okay. You don't want to send code to anybody else. You don't want to receive code from anybody else. Okay. If you find stuff online that often leads new programmers astray, and that you'll give me a solution that either uses techniques we haven't covered or doesn't really solve the problem I'm asking for. Okay. So it's best to avoid that. You can certainly look for examples online, especially on homework. Exams are different. The exams are going to be online. The exams you can use the textbook in whatever format you have it, and you can use any notes that you can take. But I don't want you randomly surfing the web. If I find evidence that you're picking up code during the exam from other places, then there'll be negative consequences for you. Okay. So the honors policy is a big deal at UVA wise. So make sure you keep up with that. Okay. If you have any disability issues, make sure you let me know as soon as possible so I can make the accommodations. That has to go through the disability services. The information's there. Okay. Sexual misconduct, any of those issues, the college has a very strongly worded statement there, and we're going to go by it. We're not going to allow that. Computer science has an issue of not being friendly to women sometimes, and I'm not going to allow that to happen. I'm not sure there are any women in this class, so I don't think there are at this point, so it may not be an issue, but any harassment of any sort is not going to be tolerated. Okay. If you have questions, Tabitha Smith is an excellent resource and she will help you out. Okay. So as far as homework goes, okay, this course is quite compressed. It's a third of the time it normally takes. Semesters are normally 15 weeks. This is 5 weeks, okay, which means we have to move quickly. Okay. And what that means in practical terms, there's no time to make up homework. So to avoid giving you the out to really get yourself behind, this class will have no late homework unless you let me know in advance, okay? And I encourage you not to have late homework, period. It just keeps building, okay? Everybody gets one free extension if you need it. Others we can talk about. But again, in 5 weeks, and the homework doesn't quit coming, we've got a lot to cover very quickly, okay? So I'll talk a little bit more about the workload here in a second, but if you don't turn it in on time, and we'll talk about what it means to turn it in as well, then you will get a 0, and there are no exceptions unless you've worked out something with me in advance or there's a major crisis in your life, in which case just keep me informed. We'll work something out, okay? So for our 5 weeks, the first week, we're going to be talking about introduction, object-oriented design. We're going to do a review. I'm assuming you've seen classes and pointers and arrays before. We're going to kind of go through and review all of those concepts, okay? Week 2, we're going to get into data structures proper, where we're going to talk about the standard template library and linked list, our first major data structure we're working with. In week 3, we'll start off on that Monday, having the midterm exam. We'll then talk about recursion, which you may have gotten to in C++, but maybe not. It's an important concept for sure. And then we'll talk about our second big data structure, stacks, okay? Then in week 4, we're going to do queues, which are the third big data structure. Then we'll talk some about searching, about what hash tables look like, and about sorting algorithms. And then in week 5, we'll finish up with the last big thing, binary trees, and B trees are a variant of that. And then we'll hit graphs at the end as well, okay? If timing is an issue, even in the regular semester, graphs are kind of the throwaway if necessary, okay? And then that last day of class, which I think is July 1st, we'll have our final exam, okay? So that's basically how that's going to operate. So let me switch over to the terminal, okay? Let's talk about the time commitment for this class. So I did some calculations here. The rule of thumb for classes at the college level are that you spend 2 hours outside of class for every 1 hour in class. So for a normal 3-hour class, you can expect on average to spend 6 hours doing reading and homework, all that stuff, okay? Well, normally that's 6 hours a week for 15 weeks for a total of 90 hours, okay? We only have 5 weeks, which gets us approximately 18 hours each week for those 5 weeks to work on things, okay? That breaks down to about 3.5 hours every day for 5 days a week, okay? So that's what we're looking at. I mean, we're looking at anywhere, depending on how quickly you get things done, 2 to 4 hours every day, in addition to watching the videos. And the videos, each chapter video is probably less than an hour, but there may be other videos that are out there, okay? So that's the time commitment that you're going to want to clear the decks for, okay? This is an important course. It's kind of the gateway course to all the other CS courses and SWAG courses that you'll take. It's a prereq to a whole bunch of things, okay? So make sure that you're giving it the attention it needs and giving it the time. The topics of this course are often a little tricky for us to get our heads around. Okay, so it may take a little extra time. So make allowances as necessary. Okay. So the other thing I wanted to talk about, we're back on the server here. This server is probably new for most of you, the Linux server. It is absolutely worth your time making sure that you understand how these things work. Okay. They're not hard, but they're different. And the more time you spend memorizing and getting good at navigating the Linux system, the more it's going to pay off in terms of saved time later. Okay. So here I am, the blinking cursor at the $sign is the prompt for this Linux server that we have. Okay. Again, there's a separate video on how to get here. So again, the ls shows me all the files that I have, the short version of that, bunch of them there. Okay. The LL gives me a long list, which shows more details, such as the size, when they were created, and all that stuff. Okay. So I'm going to want you to create a CSC 2180 directory. Okay. First, let's talk about PWD is your friend. It's the present working directory. It tells you where you are in the system right now. So everyone's home directory is /home/ your username. Okay. That's the first part of your email address before the ampersand. Okay. And when I say root directory, I know many of you, if not all of you, are of the generation where we're graphical. Okay. We're not used to the directory system. Okay. The root directory is the top of the tree of all directories. We have directories and subdirectories and so forth. So it's like, I guess, an equivalent on Windows if you open up the hard drive itself. Okay. You would be at the root directory, and / is the root directory. From the root directory, home is where all of the user accounts are. So the home directory is there. In fact, I can do a CD to home. Sorry, you have to start there /home. Okay. If you look there, you can see every account that's on the server is there. Okay. And then to get to my home directory, I can do a /home/ my username, or a CD tilde takes me to that home, my username. Okay. So again, we talked about the mkdir CSC 2180 to create the 2180 directory. I've already done that. So once you have, you do a CD to get there. Okay. So here I've got a couple of files that I've created to use in some of the videos that I've done. Okay. So all homework needs to be moved or created in the proper directory so I can find it to grade. I only had 4 students last semester in data structures, but it still took me forever to find things because I thought there were so few students I didn't need to enforce standards as far as naming, but I needed to. So we're going to do that. Okay. So for homework to be turned in, okay, we have basically chapters 1 through 12 we're going to try to cover. Okay. So if you want to go ahead and create these directories up front, feel free. Okay. So we're now in, so again, PWD, I'm in my home directory, the home DEF3QU. I'm in the CSC 2180. Okay, I'm going to make a directory for chapter 1. Okay, and I want it written just like that, capital C, no space. Okay, I can hit the up arrow key and do a 2. I can do a 3, and so forth. I can do a 4. I can do a 5. Okay, we'll stop that for now, but you can go all the way up to 12. Okay. So now if I do an ls, you'll see, and again, at least on my system, I'm on a Macintosh using the terminal application. It's color coded so I can see that my directories are in blue. I have a chapter 1, chapter 2, chapter 3, chapter 4, and chapter 5. Okay. So let's say that the goat.cpp, okay, and the goat.exe, because you'll need both an executable and the source code. Let's say that they were assigned for chapter 1, and I told you to call them that. Okay. Well, right now they're in the wrong directory. If I go to chapter 1 and do an LL or an LS, you see there's nothing there at all. Okay. So it's not where it needs to be. Okay. So a CD space .. takes me back a directory. The .. is the parent of this directory. Okay. So now I'm here. Okay. And now I can look and see that, okay, the file I want, the goat.cpp and the goat.exe are there. Okay. So I can copy them. You can move them if you want. Moving means that it's deleted from where it's at and it's only in the new place. But it's safer, I think, when you're learning especially, to copy and leave those two, okay? So I'm going to copy, it's from to, I'm going to copy the goat.cpp space. Where am I going to copy it to? I'm going to copy it to chapter 1, the directory. It'll know that, it'll be fine, okay? Note that I can't say /chapter 1. Refers to the root of the system. This is not in the root directory. I could put in /home/def 3qu/csc 2180/chapter 1. That's okay, but I don't need to since I'm already there. Okay. Okay. And that should be all I have to do. Okay. So before it wasn't there. So now if I go a CD into chapter 1 and do an ls, okay, goat is there. We're good. At this point, you can either recompile it to an executable here, or if you want to move the goat exe over there as well, we can do that. CD space dot takes me back a directory. Okay. And notice here that it does, it is showing me kind of the directory I'm in. So the pwd gives me the full thing, but this means that I'm in the tilde refers to my home directory. I'm in the CSC 2180 directory. Before I was in the home CSC 2180 chapter 1 directory. Okay. So from here, I can go ahead and copy the goat.exe into chapter 1. Okay. And again, case matters. Or you can use the wildcard and say goat star. Okay. That will copy the goat.cpp, the goat.cpp tilde, which remembers a backup file, and the goat.exe. The asterisk at the end of that is not really there, by the way. Okay, that just shows that it's an executable file. Okay, so if I do that, I can then do a CD into chapter 1. And now you see that all 3 files are there. And I can do the /goat.exe. And there it runs. Okay. More information on that, watch the video on the review of classes. Okay. So if you wanted to, now that you know it's all there, if you wanted to get rid of things here, you can do a remove goat star. Okay. When you're removing files with wildcard characters, with the asterisk, okay, be careful. So what I normally do to be on the safe side, I'll do an ls, let's say, goat star. Okay. That shows me what's going to be applied to the goat star, which is the goat.cpp, the goat.cpp tilde, and the goat.exe. I can then go back up and then do the remove and know that I'm deleting just the things that I want to be deleted. Okay. And deleting that doesn't have any effect at all on chapter 1. They're still there. Okay. So if I had assigned a program to create a class called goat.cpp in this directory, okay, for chapter 1, okay, if it's here with the source code and the executable, then you have turned it in now, okay? When I go to grade it, I'm going to go to your home directory. I have access to all your directories and all your files. I'm going to go into your chapter 1 directory. I'm going to list the files. If I see a goat.cpp, then I know that it's turned in. Okay. Now let's talk about what if you can't execute what if you can't get an executable? What if it won't compile? Okay. So if you go back into the goat.cpp file, okay, you should have more comments up here. You should have, your name, date, all that stuff. All that should be up there. Okay. If your program does not work, something like this, program will not compile. I'm getting and then give me the error that I cannot figure out. Okay. When I see that note, then I know that there's a problem. Okay. Remember, we talked back in the first Python class, if you had me, that there are 3 types of errors. If you have a syntax error, it's not going to compile. And when I try to compile it, I'm going to know there's an error. So there's no question that there's an error. Okay. So put that in here. But just because you have an executable doesn't mean that it's working. Maybe you've got a program that if they enter a number 5, it blows up and you don't know why. Put that here. Let me know that you know it's not working. Or if your program works, but this doesn't give you the correct answer, let me know that as well. Okay. It's an important concept moving forward in your programming career. If your boss gives you an assignment and you just say, oh, here it is, it's done, but there's an error, you're going to be in big trouble and very possibly could get fired. Okay. So you need to let people know where things stand. It's not a bad idea as you're developing the program to keep notes as to the bugs you still have to figure out. Okay. What I'll often do, and sometimes you'll probably see me on some of the examples. Okay. I'll put step by step. What do I have to do with this Go class? Okay. So I have to create Go class. Part of that, I'm going to add member data. Okay. I'm going to figure out constructors. Okay. I'm going to figure out the accessors. Whatever it is. So go ahead and figure out what those parts are, the print function, okay, that we're going to test in main, okay? And then you can cross those off as you go along, okay? So as a way to keep track, okay? If you so far have been able to just write the program in one setting without thinking about it in advance, without any work on paper, then you've been lucky. Good for you. You may not continue on that streak. The programs are getting complex enough. It often is going to take some time with paper and pencil first, mapping out how these data structures are supposed to work. Okay. It's also going to take more than one session when you have an error you can't figure out. If you get caught and it's not working and you don't know why, my general rule is work on it for 15 minutes trying to figure it out. If you make no progress, and to me, progress means either I'm clicking off one more feature off what I have to add, or I'm getting new error messages, because new error messages means you're making progress, at least potentially, okay? After 15 minutes, do something else. Take a walk, play a video game, get some fresh air, get a snack, whatever. Then come back to it. It will continue to work in the back of your brain, okay? If you continue to be stuck after several attempts, then give me a text. We'll try to figure out what's going on, okay? So I think that's it. Make sure that you create these directories. Make sure you put them in the right place. The easiest way is to go to the directory. So let's say it's chapter 2 week. Okay. Go ahead and make sure you're in that directory. And now when you Emacs, whatever your file name is, it's already going to be here. Okay. And that way, when I go to check, it's going to be fine. Okay. The other thing I'm going to say in closing of this video is that there's a lot of help available online. There's a C++.com, the plus plus spelled out. There's Tutorial Point. There's W3 Schools, I think, has some stuff on C++ now. Lots of available sources out there. Okay, so those are all fine places to look. Keep in mind, they may have different standards than I do as far as how I want things coded. That's okay, you can make the translation, but they're different explanations of these things, okay? Don't just read the book and listen to my video and that's it, okay? But I would avoid going to places like Stack Overflow that allow for questions. The folks on Stack Overflow are not the nicest people you're ever going to run into. In particular, if you ask a question that they think sounds like you're asking for a homework problem, then they're going to be very ugly and either be abusive to you or give you answers that are just wrong, or answers that are so convoluted that it will be clear to me that you did not find this answer yourself. Okay, if once you really know what you're doing, Stack Overflow, it's kind of a for professionals by professionals. But when you're a beginner, it's not the place to be. Okay. So I think that'll do it for this video. I would recommend when you watch the videos, again, during the exams, it'll be open book, open notes, any notes that you've taken, but not open video. Okay, so I'm going to shut down the videos during the exam. So I expect you, when you watch the videos, to take notes on anything that you care about. Okay. You can also add notes to your account, things that you find, snippets of code, whatever it is that you think is going to help you out. Okay. If you have questions, as always, make sure you let me know. Do not get behind. We've got 5 weeks and it's all over. Okay. So you really have to stay on top of this. Okay. I will see you guys then in the first office hour, whenever we determine that is.